Hello, good morning everyone. Welcome back to our lesson, that is materials, metal and the non-metal. Okay. In last class we have talked about the reactivity series and how can we keep in mind that reactivity series according to its decreasing order that we have seen yesterday. So today we are going to talk how these metals are reacting with the atmospheric oxygen. Understood? So some metals do not in need of any medium to catch fire. As I said you, potassium and nitrogen are highly reactive metal as their outermost shell contain only one electron, and so that they are very eager to donate their one electron and to be stable. So sodium and potassium do not in need of any medium to catch fire. At room temperature they can catch fire. So how other metals are also reacting with with oxygen, and what are the nature of their oxides, that we are going to talk in this today's session. Okay, so first of all I would like to write the reactivity series. Okay, and I know you how to keep in mind, so will you please with me? Okay, the metals at the top of the reactivity series, which are both potassium and sodium. These are highly reactive metals, right? So they do not require any medium to catch fire. Okay, highly reactive metal can immediately catch fire with the atmospheric oxygen as they are highly reactive and forms their oxides. So what happens? These are highly reactive metals, right students? Highly reactive. As they are highly reactive, when they are reacting with oxygen, they are forming, and generally I would like to know you first very important things. When metals are reacting with atmospheric oxygen, they are forming metal oxides. What they are forming? Metal oxides. So first of all, this is very important thing that you should know. Whenever any metal reacts with oxygen, either in presence of heat, slight heat, maybe of strong heat, okay, or maybe with even with the steam. So whatever the form it may be, right? So when metal reacts with atmospheric oxygen, they are forming what? Metallic oxides. Okay, so this is very important thing that you must keep in mind. Now we will see, as we will go down, how the metals are being reactive with the oxygen. Okay, some metals do not need any kind of heat, external heat, no need to supply. Because of their highly reactive nature, they can catch fire easily and form the oxides. So out of the reactivity series, the metals which are at the top of the reactivity series, that is potassium and sodium, are vigorously react with the atmospheric oxygen. And how can we write them into the equation form, right? The chemical reaction whenever it is taking place, that time the symbolic representation of chemical reaction is called as what? Chemical equation. So I would like to know you all in the form of chemical equation. One more time, the symbolic representation of chemical reaction is called as chemical equation. Okay, that I shall write now. See, suppose potassium is denoted by K, oxygen is denoted by O2, and it forms K2O, potassium oxide. Students, balancing of chemical reaction is not the part in your syllabus now. That you will learn in a higher grades or whenever we will get time, because that part is quite different. To balance the chemical reaction. Balancing of chemical reaction means what, student? There are two sides whenever any chemical reaction is taking place. So this chemical reaction, at the left side there is a reactant. Okay, suppose K plus O2 is at the side of the reactant. These are reactant. And it is not always necessary that reactant should be always 2. It's not always necessary. Reactant may be 1 also. Okay, as we will move ahead, I shall let you know. So this is all what? Chemical equation. Symbolic representation of chemical reaction is called as what? Chemical equation. Okay. At the right side of the chemical equation, the reactants are present, and at the left side of the chemical equation, the products are formed. Okay. The products are formed. And actually, the atoms which are present at the reactant side and the atoms present at the product side must be equal, and that is called as what? Balanced chemical equation. But here we are not going to go in much depth for the balanced chemical reaction. Here we will talk about what happens when metal react with oxygen, and whenever it is necessary I shall write also, no problem. Okay, I can balance this chemical reaction twice K2. Yes, twice K2 or 4K also I can write. 4K, then I can write here K2 or twice K2. Now it is the balanced chemical reaction. 4K why I have written? Because at the reactant side there are 4 potassium, and at the product side also there are 4. Okay, so you don't think about the balancing of a chemical reaction. This is not the task to teach you by me balancing of a chemical reaction. Balancing of a chemical reaction is a different topic. So whenever it will come, I shall let you know. But today's our topic is what happens when metal reacts with oxygen. Understood? So according to the reactivity series, every metal, how does it react with the atmospheric oxygen, that I shall let you know. Okay. So if we will balance, then it will be like this. Okay. Then the second will be what? Na plus O2. Na2O. Okay, Na2O means this is highly reactive metals, and when potassium and sodium comes in contact with atmospheric oxygen, they are forming what? Potassium oxide and sodium oxide. As they are at the top of the reactivity series, no need to have any medium, no need to supply any kind of heat of them. Okay, so I think the first point is clear for you. Okay. Now, if we will talk about the calcium and magnesium, this calcium and magnesium react with slightly heat is needed. These are not much reactive like sodium and potassium. So we have to provide slightly heat. We have to provide what? Slightly heat must be provided for them. So calcium, if we will talk, then oxygen, in presence of oxygen, this is also called as what? Combustion. When calcium reacts with oxygen means what? Burning with oxygen, and this is the symbol of heat. This is the symbol of heat, that is called as what? Delta. Means when calcium will take, and in presence of oxygen, when we will burn it, or when we will supply calcium heat, that time what will form? CaO. What it will form? CaO. See a student, about all the atomic numbers and their electronic configuration we will talk later. Oxygen, if we will talk, its atomic number is what? 8, right? And its electronic configuration is what? 2, 6. So there are 2 free electrons two electrons are needed, right? 2 electrons are needed, as oxygen is what? Non-metal. So 2 electrons it will take. Okay, it will take 2 electrons and will form O2 minus. But from whom it will take 2 electrons? From calcium, because calcium has valency 2, oxygen has also valency 2. So what will happen when calcium, when we will burn in presence of oxygen, when we will heat in presence of oxygen, slightly heat we have to provide for it. Okay, because they are exactly after these 2 reactive metals. So slight heat is needed to burn them. Okay, and we will get what? Calcium oxide. Same for magnesium. Mg plus O2 gives MgO. Okay, MgO, right? Why it is so? It can be balanced like this. Twice Mg plus O2 gives twice MgO. Okay, twice MgO. For 2 also same. 2Ca, CaO. Yes, okay. Okay, so this is what about the slightly heat when we provide to the metals, then we get a oxide, calcium oxide and the magnesium oxide. If we will talk about the aluminium and zinc, what will happen to the aluminium and zinc? This aluminium and zinc, strongly heat has to provide. It should be strongly heated. Okay, it should be strongly heated. Suppose we will talk about aluminium plus O2. Okay, aluminium plus O2, it forms Al2O3. It will form aluminium oxide. Aluminium, when we will provide extra amount of heat in presence of oxygen, then we will get aluminium oxide. Aluminium oxide is the oxide of the aluminium. Okay, if we will talk about the zinc, then zinc plus O2, when we will provide heat, it will form ZnO. Why I have written aluminium 2? Because aluminium has valency 3. Okay, aluminium has valency 3 and oxygen has valency 2. So to balance it, I have written Al2O3. Okay, so this part will be discussed later, students. No question will be unanswered. First, you learn about what happens when metal reacts with oxide. Do not think about the balancing of a chemical reaction. Whenever the time of the balancing would come, that time I shall explain you everything it did. Nothing will be unanswered. Understood? It's my word for you, all of you. But think about what happens when metal reacts with oxygen. Okay? So zinc, when strongly heated, in presence of oxygen, we get a zinc oxide and aluminium oxide. So this is the third. Then what about the Fe? The second point is what? Fe. Fe, when we start providing heat for the Fe, means iron, strongly even it is heated, then too it does not burn in presence of oxygen. Then what action must be taken? Then we convert this Fe into Fe filings or iron filings. When we crush coconut, means crushed ferrous we take or crushed iron we take. Do you know, students, you can resemble this activity with the crushed. When we crush the coconut, it forms into the filings. Likewise same, when we crushed iron, that time it is forming into the filings, and that filings can burn in presence of oxygen with a strong heat. Okay, when iron filings, when we are heating very strongly, they are converted, these iron filings are converted into ferrous oxide. So Fe plus O2 gives what? FeO. Fe also has valency 2. It is not always 2. There are some elements which will have a variable valency. Now what is meant by madam variable valency? Variable valency means what? Some elements are there which will be having two valencies. There is various elements are there. Copper is there, ferrous is there, chlorine is there, carbon is there. So these elements will have a variable valency, not carbon, but copper will be there, chlorine will be there, right? So this Fe will have a valency either 2 or 3. Okay, so Fe, if you will consider 2 valency, then this equation is balanced, no problem about it. So what it will form? Fe, when reacts with atmospheric oxygen, it will form a ferrous oxide. Okay, I hope you got it. And if you will talk about the copper, Pb, when reacts with atmospheric oxygen, it will form PbO. If you will talk about specific copper, then copper, even into the strong heating, it does not burn. Iron filings were burning in presence of strong heating in presence of oxygen. But copper filings, copper utensils. So only we are using the copper utensils for cooking purpose, right? Copper utensils we are using. This is the reason, because copper utensils do not have any effect on heating. Means it can catch heat. It has a very good thermal conductivity, but it does not convert it into copper oxide. Do you get me? Means copper oxide has a very good thermal and electrical conductivity. That is apart. But when copper comes in contact with oxygen in presence presence of heat, then it does not form up, it is not heating completely. It's not completely converting into copper oxide. Then what happens when copper utensils we keep on a gas stove or burner, then what happens, this copper oxide will form a blackish layer on it, and that blackish layer is called as what? Copper oxide. That is what? Copper oxide, CuO. Understood, students? And you may talk, what about the mercury, what about the argentinum and orium? These metals are, I said you already, these are least reactive metals. These metals are very least reactive metals. Rarely they are reacting with the oxygen. Understood? But mainly the metals which are able to react with oxygen are what? Sodium, potassium, calcium, magnesium, aluminium, zinc, ferrous and copper. But how they are reacting, that I already said. Okay. So this is all about what happens when metals are reacting with the oxygen. Okay. Now till here I have completed. Now we will move ahead. Suppose this is metal, right? When it reacts with atmospheric oxygen in presence of heat, it forms what? Metal oxide. It forms what? Metal oxide. Okay? And this metal oxide, if you will try to dissolve into the water, it will form what? Metal hydroxide. Metal oxide, suppose metal oxide, Na2O plus H2O, it will form NaOH. NaOH, okay, K2O plus H2O, it will form KOH. Understood? Mg plus H2O, it will form MgOH twice. Calcium plus water, it will form CaOH twice. Why it is so? When sodium oxide, potassium oxide, magnesium with water, means when it will react with the water, it will form what? Their hydroxides. Okay, then we will talk about the nature of their hydroxides. Okay, suppose we will take the 4 containers. Now I shall rub this and I shall explain you now. If suppose we have a 4 beakers. This is one beaker. This is another beaker, this is 3rd beaker, and this is what? 4th beaker. It contains, okay, this is contain KOH, this is MgOH twice, and this is COH twice, okay, and it contains their hydroxides. Okay students, now what I have done, I have taken 4 solutions. Okay, this is the solution of sodium hydroxide, this is the solution of potassium hydroxide, this is the solution of magnesium hydroxide, and this is the solution of calcium hydroxide. Okay, means this is the, when metallic oxides, when I tried to dissolve them into the water, I have got their hydroxides. And when I have taken a red litmus paper, students, I cannot show you here the red litmus paper, students. You have studied acid, bases and salts last year in class 7 you have done, right? And you have talked about some physical and some chemical properties of it. So in that, one important property was there. What was that? Red litmus paper turns blue into the basic solution. Okay? Red litmus paper turns blue into the basic solution. So when I will put the strip into the NaOH, then what will happen? This red litmus paper will turn into blue, right? The red litmus paper is turned into blue. For that, there is one small shortcut to keep in mind. What is that? BRB. BRB. BRB means what? Bases turns red litmus paper blue. BRB. This is small trick that you have to keep in mind. Whenever we will learn acid, bases and salt lesson, that time it will be very easier for you. BRB. This B stands for what? Bases turns red litmus paper blue, right? So what happens when we will take red litmus paper into these 4 solutions, then what will happen, students? This red litmus paper will turn blue, right? What does it indicate? The metallic oxides are always basic in nature. Understood? Metallic oxides are always basic in nature. From this, it is determined, from this activity, it is determined that metallic oxides, when we add into the water, then it forms metallic hydroxides. What it forms? Metallic hydroxides. And these metallic hydroxides are always what? Basic in nature. This is basic in nature. Understood? But all the metallic oxides are basic in nature. Now there is a different concept, students. There are certain metals who are not only basic, means the metallic oxides which behave like acid also and like a base also. Such metallic oxides are called as what? Amphoteric oxides. The amphoteric oxides are those oxides which behave like acid and base with the behave like acid and base with the acid and base. Okay? Amphoteric oxides. What is the concept? Amphoteric oxides. Amphoteric oxides. Ampho means what? Both. Amphoteric oxides means these oxides behave like acid also and behave like a base also in presence of acid and base. Which are those amphoteric oxides? That is Al2O3 and ZnO. Al2O3 and ZnO are 2 oxides which are amphoteric in nature. Means how, students? That I shall explain you. Suppose this is Al2O3. Okay? If it will react with HCl, HCl is what? Acid. Then it will form AlCl3 plus water. Amphoteric oxides are those oxides which behave like acid and base both, or which shows the properties of acids and bases both. Okay, so when I have taken this aluminium oxide and zinc oxides are amphoteric oxides. Now to show you what I have done, I have taken aluminium oxide and I have tried to react it with the hydrochloric acid. As I have taken acid over here, it will behave like what? Base. Understood? I hope you understand. If it is acid, then it will behave like what? Base. Okay? When acid and base react with each other, they form what? Salt and water. Salt and what? Water. So AlCl3 is what the salt has formed. Means Al2O3 means aluminium oxide is behave like a base when it reacts with acid. Now what happens when aluminium oxide is reacting with base? Twice NaAlO2 plus water. Twice NaAlO2. Twice NaAlO2 is what? Sodium aluminate. Sodium aluminate. It has formed what? Sodium aluminate, which is salt, and water. Understood? So here in this case, this aluminium oxide has behaved like what? Acid. And in the first case, aluminium has behaved like a base. And so that aluminium oxide and zinc oxides are called as what? Amphoteric oxides. Because they are behaving like both acids also and bases also, and they are reacting with both acids also and bases also to form salt and the water. So I hope this concept is clear for you of amphoteric oxide, which is not given in your syllabus. Even I am not going to ask you in your exam also. But as we have opt for the IIT, you must know in detail about everything, so that I have explained you. But you should be answerable. Whenever I will ask you, you must be answerable. So I think the amphoteric oxide concept is clear for you. Okay? And I said you, whenever the metal reacts with oxygen, they form a metallic oxides. When these metallic oxides are, we dissolve them into the water, form a metallic hydroxide. Right? They are metallic hydroxides, and most of the metallic hydroxides are basic in nature, except these two oxides, that is aluminium oxides and the zinc oxides. Because aluminium oxides and the zinc oxides are what? Amphoteric oxides. They can react with both acid and base, as well as they behave like acid and base. Understood? So what happens when they react with acid and what happens when they react with the base? That is given over here. If you want it, you can note down in your notebook, which will help you in your higher grades. Understood? So we'll go ahead with the next concept. Alkali metals. See students, I said you, all metallic oxides are unable to dissolve into the water. All metallic oxides, listen to me very carefully, it's very important. All metallic oxides are unable to dissolve into the water. Only two metal oxides are able to dissolve into the water, and those are sodium oxide, sodium hydroxide and potassium hydroxide only. Right? So sodium hydroxide and potassium hydroxide are called as what? Alkali. Alkali. The basis, what is the concept of base? The basis which can dissolve into the water are called as alkalis. Are called as what? Alkalis. Alkalis. The bases which can dissolve into the water, and there are only two bases which can dissolve into the water, which are those KOH and NaOH. So KOH and NaOH are called as what? Alkalis. I hope it is clear for you again. Three things we have talked about. First thing, I have told you the reactivity series, in that how metals are reacting with the oxygen. Okay, some does not require any medium, some required slight heat, some required strong heat, some filings are burning, or some metals do not react exactly but form a just layer on it. Right? So that first I have talked. Later on I said you that metal reacts with oxide to form a metallic hydroxides, and those metallic hydroxides are always basic in nature, but there are two hydroxides which are amphoteric in nature, and alkali metal is the third concept, that the bases which can dissolve into the water are called as what? Alkalis. And when metal reacts with oxygen, they are forming metallic hydroxides, but all metallic hydroxides are not dissolved into the water. Only certain metallic oxides are dissolved into the water, and those are what? Potassium hydroxide and sodium hydroxide. So these metals are called as what? Alkali metals. Okay, and their hydroxides are called as what? Alkalis. I hope it is clear for you. Okay, so now this is about what? When metal reacts with oxygen. Now we will talk about what happens when non-metal reacts with oxygen. Okay, now we shall move ahead with what happens when non-metal reacts with oxygen. Okay, non-metal if we will talk, then this is carbon, this is oxygen, carbon is a non-metal. When this carbon is react with the oxygen, it forms what? CO2. Understood? What happens Now reaction of non-metal with oxygen I will write here. Okay, reaction of non-metal with oxygen. Okay, this is carbon plus O2 gives CO2. If we will talk about sulfur plus O2 gives SO2. Okay, carbon dioxide and sulfur dioxide are the non-metallic oxides. And as I said you, metallic oxides are basic in nature, while non-metallic oxides are acidic in nature. See students, metallic oxides were basic in nature, but non-metallic oxides are acidic in nature. How it is? So suppose this is CO2. Suppose this is CO2 gas. CO2 gas is coming out. CO2 gas is coming out, or it is into the any beaker, or we can say in any test tube. And this is in the form of gas, right? It is in the form of gas. And if we try to breathe, now I had taken, I said you BRB, blue litmus paper turns red, right? Blue litmus paper turns red into the basic solution. Now which litmus paper I have to take here to show that non-metallic oxides are acidic in nature? I have to take now blue litmus paper. Okay, if I will keep here a blue litmus paper, the blue litmus paper has to turn red actually. The blue litmus paper has to turn red as this carbon dioxide is coming out from this beaker or from this small test tube we can say. But will it be, or SO2 I can say, sulfur when reacts with oxygen it forms SO2, and when this SO2 is into the test tube, because sulfur I will take into the test tube and I will provide heat for the sulfur in presence of oxygen. Here I have to show this in presence of oxygen. Then what will happen? The sulfur dioxide gas will get provided. The sulfur dioxide gas will provide like same carbon dioxide. Carbon plus oxygen, carbon. When I will burn in presence of oxygen, it forms a CO2. So whenever that carbon dioxide is coming out, and if I would take a blue litmus paper and I will keep at near to the mouth of the test tube, here also I would take, then what will happen student? Can you give answer to me? You will be easily say that blue litmus paper will turn red. But do you know student, this is the dry gas. This is dry gas and blue litmus paper is also dry. So we won't be able to see the result. To see the result, we have to make this litmus paper, blue litmus paper, little moist in nature. Moist in nature means what? We have to put some water drop in it, or we have to put that litmus paper into the water, and if we will try to bring in the presence of this carbon dioxide fumes and the sulfur dioxide fumes, then we will get what? Then we can see the result that blue litmus paper, acid turns blue litmus paper red, ABR. As I said you, BRB, this is acid turns blue litmus paper red. So what will happen here? Acid will turn blue litmus paper red when the paper will be moist. When the paper will be moist, because this gas is dry. And to see the acidic characteristic, water is needed. Water is performing the role of a medium to see the characteristic. As we have said into the metallic hydroxide, because water was necessary only. Because of that, metallic hydroxides are alkalis, we won't be able to show you. But here what happens? To show them acidic characteristic of these gases, we have to moist the litmus paper. Understood? So moist litmus paper, if you will try to keep in the mouth of the test tube, then we will be able to see that blue litmus paper will turn red, and it will show that the non-metallic oxides are always what? acidic in nature. Okay. Now what happens when this non-metallic oxide react with water? When non-metallic oxide react with water, they are forming their hydroxides. What they are forming? Hydroxides they are forming. CO2 plus water, when it will react, it will form H2CO3. H2CO3 is what? Carbonic acid. It is what? Carbonic acid. Okay. When carbon dioxide reacts with water, it will form H2CO3, that is carbonic acid. When SO2 reacts with water, it will form H2SO3. It will form H2SO3, that is called as what? Sulfurous acid. That is called as what? Sulfurous acid. Do you know, student? Non-metallic oxides, when come in the contact with water, they are forming acids, and this is only causes acid rain. Acid rain concept you might have learned before it, right? Acid rain. Acid rains, why it is causes? Because carbon dioxide and sulfur dioxide, when comes in the contact with the water, means when the water is coming out through the rainwater, that rainwater is mixes with SO2 and CO2 and forms the acid rain, because carbonic acid and sulfurous acid has formed. But it will not very harsh, means if you will try to take a rain bath, means sometimes we like to play into the rain. So that time what will happen? It will not be very much, we can say, concentrated acid. It will be mild acid. But this acid rain may cause damage to the aquatic ecosystem. Understood? So this is what? Non-metallic oxide. When react with water, it forms a carbonic acid. This is CO2 plus H2O forms a carbonic acid. This is SO2 plus H2O calls a sulfurous acid. Understood, students? So this is all about what? Reaction of metal with oxygen, and what happens when non-metal reacts with oxygen. Metal reacts with oxygen to form a basic salt, and basic in nature, that is, and when non-metal reacts with oxygen, they form a acids. Understood? So this is very important. Actually, chemistry is interlinked with each other. This will help you while studying acid, bases and salt. Okay, if I would be there, I shall explain you, I shall interconnect to you, and in detail I shall explain you everything. But there are certain metals, that is NO2, H2O. These are neutral salt. These are neutral. CO2, this is also non-metal, but their oxide is neutral. This is also working like sometimes non-metal. This is also neutral. Okay, so acidic, basic and neutral. Okay, so this is all about what happens when metal and non-metal reacts with oxygen. I hope you get it. Prepare your own notes. Without fail, prepare your own notes, which will help you. And then too, if you have any doubt, you may ask me into the Google PS period. Okay, Google Meet when we take during PS period, that time you may ask me. So thank you so much.